This is IBM Museum. In this video, I'm going to go over installing a memory adapter on an IBM PS2 model 55SX. We've seen this particular model in the past, and the memory adapter specifically is a 2 to 8 megabyte memory expansion adapter, 16-bit. And it's also further identified that it uses 72-pin SIMs. Now in this video, it's going to be a little bit of knowing where to find information online. I'll have links to those Louis Olin pages where you can look at these adapters. There's diagrams, there'll be pictures in some instances, even high resolution pictures. And then there's notes that have accumulated over the last, 3 decades, sometimes, on how the specifics are for these adapters. There's new versions, how those new versions are identified, the IBM FRU system, that meaning the field replacement unit, going through and finding an adapter that is, whether it's a functional equivalent, or it's, in other words, a field replaceable unit of another adapter, or whether it has a newer FRU sequence, to identify it that it's actually an upgrade or something else. And also within this video will be a little bit of the introduction to, and I've covered this before as well, the EC notion, engineering change, and how IBM went through and marked particular parts, pieces, had labels, stuck on things, had it identified in some of their literature for this big list as they went through. And you would look up an EC change that tell you what it affects, what models, what parts, and a lot of the specifics, what bugs could happen, what to replace on unit to basically fix those engineering changes of what to do. And typically they're going to go through and have a listing and even talk about if you have this FRU, you're good. There's nothing needed to change. But all these other FRUs, the previous ones, are what they call down level or are due to be replaced because they had bugs or something else happened to them, that IBM went with that newer part and marked that EC change. And those EC changes are just as important as those bodge wires we see on circuits. They went through and figured out that the circuit wasn't as planned. They even in some cases added chips glued to the planers or adapters and had those little wires running around, tacked down, that really delicate soldering and things like that. And so that knowing the things out there, and a little bit of the notes that we have online for reference, as I say, Louis Olin's and other references of the members of the comp.sys.ibm.ps2.hardware news group, SIF, have contributed over the years, and to look at that and quickly get the information that you need. Their troubleshooting steps in some cases of going through and what actually changed, or a way to go through and get around a particular problem. Later on with some of the memory adapters, we're going to deal with something particular. It's called BOPT, bypass. And I draw a blank right when I bypass problem temporarily. And I'll get a little bit more detail, and I'll be corrected in the record, no doubt. For comments that come, I'll try and put it in the video description. But going through and, the sequence that IBM came with to go through and to get around a particular issue and what the steps you had to do. Now, with this 16-bit adapter, and we're going to go through and we're actually going to fire up the 55SX. I do have the reference diskette there. The front of the machine is off to the left. The back of the system is to the right. We're looking across the system laterally. And I do have the original adapter in the slot right now that's there on top. I have a later adapter, and we'll see some of the specifics for it. And we're going to go over even little picture details and all that to show how these adapters are different, what may be improved. I do even have one SIM module laying there on the power supply as well. We'll kind of learn what that'll be as well in this process. And both the adapters pictured here right now as it stands, even though the labels may be different, that adapter that's in the slot has the labels on the SIMs. The lower one does not, but all those are identical 2 megabyte 85 nanosecond SIMs. They're all the same part number. They're all the same physical layout, whether they have the labels or not. And I do have some of the unpopulated adapters, which I've taken pictures over, in front of the unit, as you can see off to the very left. And this particular Model 55SX has 2 4 megabyte modules on the system planar. And I'll go through and I'll actually kind of point around and kind of show the placement of those. But the thought is with this system that it's got 8 megabyte on the system planar. And so another 8 megabyte would be perfect for reaching that system maximum capacity of 16 megabytes. That's as much as a 286 CPU or 386SX CPU as the instance here, one that has 24 bits of address lines, 24 separate address lines, is able to address a maximum of 16 megabytes of memory on the system. And so having that 2 to 8 megabyte adapter in the slot is the one that we're working with, and it's with the 55SX, the 16 megabyte, a 16-bit microchannel bus, and so on that adapter is that 8 megabyte, 4 SIMs of 2 megabyte apiece. So we reach that 16 megabyte maximum of the CPU, but we'll find out in some cases that can actually introduce an issue. So let's go through, and I'm going to go off screen, and we will actually go through to start this unit up and have that reference diskette, have the video captures of what's on the screen to show this. And this is one take as it is, and just rolling straight through. If we hit any bumps, we deal with them in turn. So let's get started. Okay, and just briefly pointing out on the system, The two 4 megabyte SIMs are down here next to the power supply, underneath all this riser support, all the cables, power wires, and things like that. This is the adapter that we have inserted in that 16-bit microchannel slot right now. And, first SIM, second SIM, third SIM, fourth SIM as they're marked. CN1, CN2, CN3, CN4. And then we have the more newer replacement of that. Same SIM arrangements, same EEPROM, and we'll learn what aspect that this EEPROM is in that. So, and then as I say, I've got the older adapter and new adapter here with the unpopulated SIMs, and I've taken pictures of that, and we'll go through pictures later on. And then I have this one SIM here as well. And although these other SIMs are 2 megabytes apiece, this is 1 megabyte on it. And so we'll learn about that aspect. So let's go through and let's get the system booted up. I'm going to switch the screens around here, and we will go with that with going through and booting up on the screen. And I'll just actually describe the steps I'm doing there when I put in the reference diskette and things like that as well. Okay, and I'm going through and I'm powering up the system. And I'm going to go through and actually... okay. So we have some beeps. And I don't see anything displayed on the screen. This would be one of the handy occasions to go through and beep codes are, typically, hey, I'm not able to display video. So let's go ahead, power the system down. And I was treating this as these adapters. Let's get through a troubleshooting cycle then. I'm going to go through and we will get the system back up. Okay, one of the first things I'm going to do is what is the last thing that was added? Okay. And so we're going to just slide that memory adapter out and power on. Okay, let me get the... okay, so there we have the screen. The going through and powering up, counting up to the 8 megabytes that's on the planer. And since it's actually changed the memory configuration on the system, it's going to want us to run through the configuration. I've got the reference diskette in there, and as we know, a little bit of the beyond the first models of the PS2s that came out in 1987, most of them are able to get through the if you have the reference diskette, they're able to boot. So we're going to say automatically configure the system with that 8 megabyte. And this is actually great that we're getting these troubleshooting steps in here as well, because I just pulled these adapters out. I mean, I had this newer one for the reason that I've gone through this process in the past, and I've been aware of what this fixes on the system, and you can't see where I just pointed to, but I pointed to that new adapter that we have seen on the or the newer adapter that is on the power supply with all those 2 megabyte SIMs. And I know that works. So here in just a moment, we're going to, once I boot up, and I'm actually going to eject the reference diskette. And on this reference diskette, I've gone through and I've copied over in a later process, because this system, I don't know if you've kind of noticed, but it has that, what's called the Procom Pyra, or the IDE, the ability to run the IDE drives from that replacement riser that's on the system. And I've already got the ADF and the needed files on that reference diskette. And okay, and this actually has we've seen this earlier on from another video of that Cyrix CPU that's on there. So we've got to the point where the system has booted up. And let's go through. Let's get the system up again. And so what we're going to do, we're going to power off the system. And what is the one thing that we can do? As I say, I've got, this adapter is an unknown. We've pulled it out. It looks complete. I know I do have one that's still in the drawer here. And it's actually got one of the broken latches, and we'll cover that aspect later on, to the SIMs. And then it's got one of these delay lines, and the chip is broken, split off from the surface mount. And that is likely going to be a later repair video as we get in there and solder that back on. But the next thing we can do, since I have another board, and again, this is kind of an unknown as we could view it. And this is the one that I took pictures of, although in this case, that there's things like the label of the EEPROM, and that's a little bit scratched up. And I should have these so-called thumb screws loose enough. And a lot of time, in one little thing that you'll notice with these microchannel cards as well, we may actually hit upon a little bit of that aspect in a moment. These are pretty thin pieces of metal, and these little flaps always get bent out of shape because it hangs up on that screw, and people shove them in and bend them over. And that's the common part that you'll find that is you sometimes have to get in and get back into position. Okay, so we have that adapter. No SIMs populated on it. And I do have even other SIMs. If we still get some kind of, wow. And that may have been it. When I went over it just now, that SIM was a little bit out of position, but I don't think that would necessarily bring things to a halt. Okay, and then we have trouble in paradise there. Little bit of trouble in paradise here with those plastic latches. And again, that one's busted off that holds the sim down. And people go through and they even will hot glue and things like that down. Now, what I'm going to do here, and there might be no other way, that when we have the system powered up, that I just kind of hold that down. And if we get it to boot up, I might go through and actually switch back into that other adapter just to see if we can identify what the faulty component is. But, common troubleshooting step is go board level replacement. Go through and swap out a part for another part or a known good part or something that just break the step in half for every step that you go through, or break the process in half, where you go through and we can quickly determine whether we have a bad board or bad sim or something like that. So let's go back to the screen capture. And I'm going to hold down on the sim as I fire this thing up. I'll wait till we get beep codes before okay. And we see it counting memory. And I'm going to put the reference diskette in there because it's going to want to configure the system. And we may see something else come up in that aspect as well. Okay, and it counted the planar memory since it has not enabled the memory adapter yet. It did not count the memory on it. Okay. Automatically configure the system? Yes. And we may go through and be able to show the issue in particular that I was looking for. But I am interested in determining whether I have a bad adapter or whether it just maybe was something like that sim just wasn't in there or something else. Okay, so we're going to press enter. I'm going to eject the reference diskette. Goes through and counts the memory. And we should see the sequence where it goes through and counts that 8 megabyte on the planar, but then it slows down a little bit when it goes through and starts counting the adapter RAM. Okay, that's what I'm saying. Going to go through and count, and remember, I've got to hold the sim in through this whole process, just because of that broken latch. And we'll see about those broken latches. And, I'll go through and if I have a functional board, I can go through and see what I can do to make it work in that case. And I don't necessarily want to glue a sim in there, but coming up with some case, some way of repairing that and working with these old parts and that plastic piece again, and me or someone else in the past and the way the card is stored or something else went through, or just rough handling and pulling a sim out, because that plastic can get brittle over time, and you go to move it one day and it just breaks off. And it has taken its sweet time. And I'll really enjoy whether I can check on this this adapter later on that we pulled out. But it's nice that we went through the warts and all. Okay, this is what I wanted to show. Okay, it put up this particular code, 19498, and then this dash and this 16256. That looks kind of like a memory amount reference in a way. And normally you're pressing the F1 key here. And that put us into ROM Basic. Okay. Even though I hate... Okay. Now let's do this. I guess as an exercise. We're going to power it off. I'm tired of holding the sim in place. We powered the system off. Okay. And here we are with that loose sim. And I'm going to go through and just put that off to the side. And we're going to go through and we're going to power up the system again. Let me switch over to the video capture. And at least it has 2 megabyte less of memory to go through. And of course it's going to want to, I'm going to insert the reference diskette anyway. Because I feel that with that 2 megabyte less on the adapter, it's going to want to go through and configure the system again. The memory amount has changed on the system. And normally for every instance of the system parameters, what equipment is there, if any of that changes, all that configuration that's stored in non-volatile RAM, if it's any different on your next boot up, that's going to be the response of a PS2 system where it's going to say, you need to reconfigure me. You need to run that reference diskette again. And there are systems, and the low-end Model 25 and Model 30 that originally came out that are based on the 8086 CPU. Those are a little bit more unique in that instance, where they don't have a CMOS RAM or non-volatile RAM that backs up that configuration. Those systems are designed, and they're very simplistic in that regard, but they determine equipment configuration on every boot. And there, we didn't see any error message, and it didn't ask us to reconfigure anything again. Let's just go through and I mean, if you change the memory amount on an adapter, it should track that as well. Okay. And as I say, slot 3, if we look, and it's showing installed memory, and that's your planar RAM up here, the 8 megabyte. Usable memory is 14 right now, and because it's 16 megabyte minus the 2 megabyte sim. And then it gives a parentheses of that 13.9, and that differs from, or it's a translation of that 14 megabyte, I guess is the way to say it. And then, so yeah, install memory. And install memory, that's talking about what's on the planer. Okay, and then down here, okay, and we've got, it's the 2 through 8 megabyte 8286 or 8386SX memory expansion option. And onboard RAM, or excuse me, onboard ROM address space. So that EEPROM that is on the adapter, it is at a defined location in system memory. And basically you have different expansion ROMs, and those have the ability to, it has to run through that code for those adapters. Two different adapters can have a ROM expansion BIOS on them that has to run, and that can't conflict in the address space for those two adapters. So the reference diskette will go through and make sure that you're not having conflicts with things like that. And see the and that base adapter based memory address, that's effectively dealing with the ROM BIOS extension that is on that Pyra 55, and I think that's Procom IDE replacement adapter or riser adapter, and then the 55 for the 55SX. So we've seen that the system goes through. I'm trying to think if we want to go through. I mean, and we're not going to go through any involved thing like the displaying the memory map or anything like that, but within the change configuration, we can go through and actually toggle through the F6 next and F7 backward for going through and toggling through those different settings to adjust that. What the system is auto configured as. But that automatic configuration that tries to avoid conflicts if it's ever possible. Some adapters do have what they call fixed resources, in that they, those are not modifiable. And quite a bit of the time of what is on the system planer is treated as a fixed resource as well. And yeah, I don't think this is really going to. Okay, well, it's a little bit helpful here because the memory not being used, size, and just 112 kilobyte. And then it gives a space there of the slot 3. And this is actually the ROM BIOS extension, because it says slot 3 size 8 KB. And that's ultimately the ROM BIOS extension size. And then getting down to slot 4 for the Pyra 55, size again of 8 KB. And that is dealing with the ROM extension. This is not, for all that, it's not necessarily the, well, it's a little bit dealing with a little bit of the RAM aspect, but also the ROM. Okay. And let's go through. Excuse me, I have to remember my cough button again. Okay. Let's go through. We're going to go through and exit. Okay. And remove the reference diskette. And we hope in a way that this doesn't turn into a big long video, but you know, we're rolling and we're learning. We just roll with whatever comes up. We get beep codes, we go through and troubleshoot. That's part of that learning experience, having problems crop up. And that's why I'm saying these references and other things are helpful to learn. And where those references are, how to page to them, how to, you know, kind of get caught up with the various adapters. And I can actually link the pages of this memory adapter that I'm referencing here that we're trying to install. So you can see those diagrams and see the explanations and notes and things like that. And and of course the RAM count is slowing down. And so getting through, and we'll see this in pictures later on, the adapter that we're putting in there right now, this 2 through 8 megabyte memory expansion adapter, and it's the at f7f7.adf is the adapter description file for it, that you'll see on that page reference. And the part number, and we'll see this in pictures, is 15F8292. And as I talk about the ROM BIOS expansions, that's part of that Pyra splash message that comes up in the that's code that actually runs from that EEPROM. I just had a I had a light come down on LED light. Of course, I didn't have it up on the shouldn't up on the screen, but I may have to. I've got that stuck up on by Velcro. I don't know why it came down. I'm not pulling on it, but I'll probably at some point I can pause the video and I'll get that all reconnected. All it does is it kind of dims. There I'm operating off half of the LED lights now, which may not necessarily be a bad thing. I just may wait till daylight as well. So this went through and it booted up all the way. And I kind of expected that. And so let's go through. Let's get the screen capture up. Actually, okay. And that's really not all that much dimmer for you guys, so I'm not going to sweat it. Okay, let's do this. We're going to power the system off. We're going to go through and we're going to pull this adapter out with the broken SIM latch. Pull the SIMs off of it. And it's just a gentle touch. These things pull off to the side and the SIM pops right out, but for whatever reason, and it can even be storage of these things. Okay. 2. And you know, notch in this case is to my left. Okay. And we hear that latch in place that time. But we are trying that adapter that we got beep codes before. malfunction here. I have less light to see myself, even though it's not necessarily visible to you guys. And we have that new kind of riser without the battery bump in there, and it actually latches in that front tab, and that's kind of handy. So that's the, you know, the later replacement that IBM did for that. We saw that earlier one with the bump, and then IBM says, hey, no, we've got to go through and put a latch on that adapter support. So we have that adapter in now. It'd be interesting because, you know, that's got effectively the full 16 megabyte again. Let's go ahead and power up for now. Okay, so it may have just been something as simple as that loose SIM that I noticed. Okay. And we're going to shift over to the screen capture again. I'm not going to put the reference disk, well, yeah, let's go ahead and put the reference diskette in there. There's a method to my madness. Okay, so we got the configuration error, but that's fine. Okay. Yes. Let's let it go through that routine that we originally wanted to go through, even though we had to go down that troubleshooting rabbit hole. And now we know that that one SIM has a broken latch, and that's fine. Okay, it's complete. I'm going to leave the reference diskette in there. As I say, there's a method to my madness, but we're going to see if we get any errors. I'm expecting an error actually to come up on the screen. Yeah, this may actually take a long time to upload once I'm through. But I do like going through and using the method here that I can just take the video and okay. Now, to me, in a way, that was, I don't know. That's interesting that V2. Okay, well, okay. So we're getting into the reference diskette, set configuration. Okay, let's view configuration. Okay, install memory, of course, is the same. 8 megabyte. Use what? Ha. So we find out what was beep codes before and why it all of a sudden said, hey, you got to reconfigure. We have slot 3 as empty with that adapter being in there. So that thing is dead. Huh. Okay. And I'll probably even... Okay. So... just that. Okay. Ejecting the reference diskette. We're going to press enter. As it works through, okay. I reach into my bag of tape. And even this is typically what I call these, this adapter now that I have in there. I call those visibly complete because I can take pictures of it. You know, it looks like it works, but it doesn't. As long as I have it marked and I don't mix it up with my adapters, we got to see a wart today in that we found the bad adapter. Okay. And it looks like we're to the nothing spinning on hard drives, so we're gonna it went through and got all the way fully to the prompt. We want to be gentle and not get these things out the wrong way. So this is bad. So I'm about to do my troubleshooting step that I was interested. The whole concept of this video was I'm going to hold that sim down again. And we kind of get 15 minutes later, we get to the point of putting this back in. And it's too bad that this it's too bad that that SIM slot is broken, but we know that the adapter, and even that one, even that CN4 position, which should be the last But I'm glad I went through these troubleshooting steps to identify that bad adapter and didn't have where trying to fit it on a system later on and getting, you know, having to go through troubleshooting steps at that time. So memory amount is going to change. That means that we'll put in that reference diskette and power things on. Oh, I need to look and see. I should have actually pulled. And you can do this. The system is going through and powering up. We're going to just, no harm in that, cutting that off. My fix everything. I don't want to use masking tape because I'm not, the stick on it would probably, this is what I'm doing. I'm unsealing a big roll of Fix-It duct tape. And, you know, in the shop here, I have this organized. It didn't really rip very well, but I've got a little strip there. And you can now say, IBM Museum does what? He uses duct tape to fix his PS2s. And I may have to go through, as this thing goes through a slow boot cycle, I may have to even turn on the, and this, you know, shouldn't be conductive or anything else, but I've got, that'll give me the stick. Okay, let's power this thing on. We will get it switched to, and the reference diskette is in there. Okay, and as this goes through and boots up, I'm going to mute my mic, and I'm actually going to light the heater again here. So I will be right back. Okay, and we get the beep, 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 and then it wants to run, and I'll go through and get all the references to get started as well here. Okay, automatically configure the system. So I'll use an appropriate point here when I can to, or just bear through a little bit of the temperature. Okay, enter. But at least I'm not having to hold down that sim. Okay, let me mute the mic and get the heater started. And for all that, it's still counting. And again, we have the reference diskette in the drive. And I even got the step stool close to put up the light when we get a chance as well. Okay, so we got that particular error again. And of course, it's booting to the reference diskette. Enter. Maybe I'll list that error. Okay, unusable expanded memory. The 19498 error. Amount of memory installed in this system exceeds the amount of usable memory. This error will continue to occur as long as the total installed memory exceeds 16 megabyte. You may continue normal operations by pressing F1 key after this error occurs, but only the memory below 16 megabyte will be used. And we had to go through and even, have the reference diskette come, show this error, even though, and let's take a look. Okay. View configuration. So there we have the installed memory, usable memory, and 15.5 megabyte. Installed memory is the same, and we've got that working adapter, functional, showing the EEPROM address space and all that. But that's kind of the error I wanted to show. I don't know what really the memory map will show. Memory not being used, same amount. So ultimately, just the combination of those SIMs just so happens that it exceeds somehow the 16 megabytes. And, with all the kind of carryover, I guess, of the whatever bits, wherever, I don't know how it's counting, but that is just something that's happening here. Okay. So, eject the diskette. Enter. And we'll get probably that slow count again. Yeah, this is going to be a long video. Wow. Just to hit kind of these checkpoints in here that I want to, or these things that crop up that I know about from my involvement with the systems. Okay, and then counting that expansion, the adapter RAM, slower. And I still have to cycle through a little bit of the pictures that I have too. And that SIM, even though I have it duct taped down, it's still sitting a little high there. And all I'm doing is I'm pulling it down just like the latches would hold it to make contact in that little, where the electrical contacts come in, and fits in there and basically contacts that edge. Okay. So here, even with that error, because it told us that we pressed the F1 key, that drops us in the wrong basic. So that it's really where what it was telling us before is, hey, if you go through and press F1, you're going to be able to get out of that fatal halt, or where it stops, the system stops and gives you the warning message, and be able to boot to the hard drive and get in the operating system. But this is throwing us into ROM basic too, just because there's a little bit more memory than what the system expects. So let's get that up on the screen. We're in ROM Basic, so we're just going to power down. Okay, now it's nice we'll use this little springboard. I mean, this is supposed to be the third position sim, although it really shouldn't matter in the grand scheme of things. All these slots are identified differently and run by the memory controller. They don't necessarily have to be matched size. But think about this. What's the reason I have this 1 megabyte sim out? I looked through, I searched through, and I mean, these things can be run in like the PS2 Model 50Z and stuff like that for that one sim slot, 72-pin sim slot the 50Z has. It can, I think you can have the 2 mega. A lot of my 50Zs I go through and I try and think to have those run the 2 megabyte sims. I think they're able to do that. I don't think they're restricted to the 1 megabyte. But these 2 megabytes are pretty heavily utilized by me as well, even though they're 85 nanosecond. But on the older systems, I mean, the older PS2s pretty much recognize those if the sim socket doesn't take a doesn't take a 4 megabyte or 8 megabyte or whatever. And so let's do this first. Let's pull that 2 megabyte out of there since we've got a broken sim latch. And I reassure you that I did not do that to go through and certainly if it prompts for the reference diskette, we'll let it have it. But I'm going to have the reference diskette out of there for the moment. We start that slow count on the adapter RAM, and we are at least not having to, we're counting 2 megabyte less, at least in this instance. And what about that error, that warning about exceeding that 16 megabytes? If we take that 2 megabyte module out, are we going to have that error? Probably not. And like I say, that's just really odd that I remember this error that you could press the F1 key and you didn't have to have the reference diskette after a while, just like the error message showed, to say, hey, I pressed F1, resize the memory, and continue. And the systems were able to continue. But there for some reason. And that, who knows, that may be the Procom riser and IDE drive that I have in there as well. Since that's a little bit different than what the 55SX expects, those DBA direct bus attachment ESDI drives are more fundamental to the system. They're treating that's going to be the drive that's normally there. Okay, and it didn't prompt us for the reference diskette, but what is this? Why do we have a blinking? And so maybe now it's thinking about that it's, hey, that adapter should have had 8 megabyte on it, and since it doesn't, I'm just doing the control delete key sequence. We should be able to get through without the memory count, and I've got the reference diskette in there now. And who knows, we could find out another wart that the the sims have to be in there in particular positions or something like that too. That we can't have that slot vacant. It's got to be another slot, or who knows. Now, it didn't go through. Okay. Okay, and we're back to kind of where we were 20 minutes ago. Okay. That usable memory and being below 16 megabyte now, no error. Okay. Let's do that. Let's just have it. Let's just have it run automatic configuration and go through and maybe redetect that. Okay, it's complete. Enter. Okay. Configurations changes have been made. Eject the diskette. I want to get to the DOS prompt again. That normal sequence of going through and counting up the 14 megabyte before we go on to the next step. And we'll even have to see if that requires an automatic configuration. And then I've got to get to the point where I kind of display what I'm, the concept I was working from there, the reason for the video, and then get showing the pictures and get the video wrapped up, get it online. Because I don't know how long this thing is already. And it might be something I just have to get on the USB stick and get it down to a location where I've got a little bit better upload to do it 3 times quicker on the upload. Slow count, slow count. But heck, life is like this, right? Just a lot of hurry up and wait on the RAM count. At least we're only having to count up to 14 megabytes. Okay, we got the riser, got the beep for boot up. Okay, great. And I'll probably still get a little bit of flack of running himem.sys of testing that extended memory. I don't necessarily have to. Just another delay in the video. But, okay. Aaron, the config sys. I'm not going to really... Huh. Okay. I don't know why it's flagging those errors as well, but we effectively have gotten to the DOS prompt, even though we may have to necessarily tell it what's going on. Here's what I'm going to do. Okay. This 1 megabyte sim, that was the concept here, is that we could go through, let's tape this down rather than hold it again. You know, we were holding the 2 megabyte before, but let's get this 1 megabyte sim in there. So 2, 2, 2, and 1. Instead of 8 megabyte, that sim, we have 7 megabyte. Powered on. Ooh. Give me just a moment. I don't see that sim down in the socket like I may just be looking at it off angle 2, but it didn't look. Yeah, it looks better. Power on, and we will get slow count. And the thought is we should be counting to 15 megabyte now. And we are below the 16 megabyte area where it complained about that. So we should not get the error. We do have the reference diskette out. And we'll have to see how it boots up from here. I don't want to mess up where I've got that hard drive messed up and go through and where I get things corrupted somehow. But and we'll see if it's with that adding that 1 megabyte back in of whether that megabyte went to the please. But at least we didn't get that beep code, and so it's not complaining about that 16 megabyte being slightly over the 16 megabyte. But something is not happy. So I hope I didn't mess something up here. Because that's the point where it would count. Hi, ma'am. Okay, so power the system off. Okay, and it's time to, and we want to see if we can get where we didn't mess something up on the hard drive. Get that board there. What I meant to show with this, and as I said, this adapter here was in the system before. And, as I've referred to earlier, again, we have that Seiko Epson Japan logo on the chip here. On the back, even gives a part number like it's a adapter for a Seiko Epson. And even though they, as far as I know, they didn't have a microchannel system of their own. They had a MAL 30 clone that was very similar to what IBM had in the MAL 30. Okay. And I'll show the pictures too of what this EEPROM and things like that. But let's get this powered up. Now that it's seated. Okay. And that's maybe just another time for. And I didn't see any notes on this adapter on that where it reports that you've got to, if you lower the quantity of a SIM, that you've got to do it in a particular order, or that that fourth slot basically first if you're reducing any RAM. And certainly I can go through and try that on my own and kind of maybe give an update from there. I don't want to really extend this video any longer than what we've hit on so far. Okay. And I think I'm actually pop. Yeah, let's go ahead and pop the reference diskette in there. That'll be a little bit more conducive to where we're trying to end up, or if we're to get an error message about the memory being slightly over 16 megabyte again. We've got that reference diskette in there. And it counted to 15,872. So didn't really count above 16 megabyte in that regard. Okay, enter. Set configuration. And that ID hard drive, man, I hope that thing is not going out. It is making a little bit more noises. Now with this other adapter, we have same installed memory, of course, being referenced to the planar memory. Usable memory, we've actually got it as 15.5 megabyte. So not quite. And you can certainly go through and rewind and all that for the video later on to see what it reported for the we're going to run automatic configuration just because we can. I just want to make sure that I've got that adapter in there. Anything that the reference diskette could identify otherwise. Is being dealt with. But let's go ahead, and I hope in this case that this process, we'll have to see what, if we get any errors come up, and see if we are able to boot to the hard drive. And I don't necessarily know if data is corrupted other than maybe like a config sys or something like that. if that's the, it acted like it was not able to do load the particular drivers from the config sys, or had trouble something with it. And that slow count to the 15.5 megabyte. But at least it's warming up here in the room. Wow, that took a long time. Okay, fingers crossed. Okay, IBM launched. And that's called from within config sys, so that looks good. We might have just been confusing the system and, like I say, unpopulating the sim sockets the wrong way or something there. There we go. And that's the driver for the Cyrix CPU is loaded in there as well. And if that's not loaded properly, then you're going to have issues as well. So you notice that we're going to go back to the SkyCam here. Okay. So you notice we have the adapter in here, and we have all these are 2 megabyte modules. And so we have the same amount that we had on that other board, the one that we had working, but we didn't have the memory size there when it booted up. And that's because there was an engineering change for this adapter. That was the version 2 EEPROM that was on the old adapter, or that version of the adapter. And this one has a particular FRU 57F2905. And that's just known as the fix, where it goes through. There's an EC number, ECC 33039. So that's, IBM would have that identified in internal documents. Hey, this is the EEPROM that you need in there to update that adapter to where it doesn't complain about the RAM size, to resize it and continue, because that process is all automatic. Why can't that be automated to where the system recognizes, hey, yeah, there's a little bit extra memory, but we don't need to notify nobody of it. Just resize it and continue without complaint. But it took that EEPROM having new code on it to effectively make that change. And so that's what I kind of want to point out here, or the notion in this video is those later EC changes fixed a particular issue that occurred. And I'm going to go through and I'm actually going to show some pictures, because more than just the EEPROM was improved on that change. And actually, for all the FRU labels and everything else, that's all that changed on the adapter for the code side. You could go through and you could burn an EEPROM and of the newer code and put it on in place of that version 2 EEPROM, and that would function just like you had the updated adapter without the other physical things that I'll show here in a moment as well. So those ECs and knowing and having that background information on adapters that you're using can be very helpful. Just knowing the ins and outs and things like that. I'm going to have a little bit of a shadow as I go through, reach up here on top. And this came in the mail today, packed very well, separated. He took the tab off and everything else. And this is from Jerry in California. I've known him on the SIF news group for a long time as well. Active participant. And he's going through and he's reducing what he has. He told me this adapter, I don't have any system to test it in, so sorry. But I wanted to purchase this, even though I looked through the news group and I'd found out I do have versions of this. But this is the regular microchannel 16-bit ESDI adapter. And so it used more of a conventional ESDI interface and the control, the two control and the data connections. And that was typically a 5 1/4 drive that was big, had a separate power connection. So that was typically for the a little bit upper level of the MUL 60, because the lower level MUL 60 came with an MFM drive, or initially came with that MFM drive, and then they released later versions of the MUL 60 that had this ESDI interface, and then the low end side of the MUL 80 had ESDI as their starting hard drive controller, and later on the higher levels had a SCSI adapter in them. And the 65SX, it shares the case, and that's a 386 16 megahertz. I think I said the SX in there, 386 SX 16 megahertz, and that's treated as the tower version of this desktop 55SX. It's a complement tower, since they have kind of the matching MUL number. So 55SX for the desktop, 65SX for the tower version. And the 65SX came out later than the MUL 55SX. So they added on some things that came out at the same time that IBM released what they called the 55LS, the LAN station, that had the floppy drive but removed the hard drive, didn't have any local hard drive, and that system booted over the network, changed out some of the components on the planar. But the 65SX was being the tower. It's kind of a hodgepodge, and IBM, even though it's a rather dated processor at that point, they put in a SCSI controller called the Tribble, and that's normally a 32-bit adapter but can be run in a 16-bit mode for the 65SX, having all 16-bit microchannel slots, just like the 55SX. And they also put in the XGA video adapter. And that's also the same thing, a 32-bit adapter, but able to run in 16 bits for that purpose, just to pump up the 65SX in performance a little bit better. Give it a little bit better hard disk system of the SCSI and then also the XGA. And I've gone through and I've already done. You're saying, David, get to the point. Get to the point. I've already done a what's called SCSI level for the SCSI controller side. Those Tribbles, those Spocks, those Corvettes, those the enhanced Corvette, to where it tells the microcode version on these IBM SCSI adapters. The ones that aren't rebranded from like Future Domain, like the Patriot, the authentic IBM SCSI goes through and it has a microcontroller on the SCSI board, just like a lot like this ESDI adapter. This is the microcode for the controller, the SDI controller, these are the ROM extension chips here. And that basically tells the system of you could have even a larger capacity hard drives that are possible with that. But this microcode version is also pretty well, because they did find bugs in these and stuff like that and go through and make the same EC changes throughout time. And I bought this adapter from Jerry because it has the latest microcode here for these ESDI adapters. And okay, I was looking to see, I had this separate, oh, I got it right in front of me. And this is and I have these screws loose, so I want to set this down for a moment. Tilt this over. This, and you can see that 72-pin edge connector, both sides, 36 pins, both sides. Pin down these screws. And that's the DBA ESDI driver that has just that long, wide connector and power and data over that, and 3.5 inch size. And IBM used these. They had these from 30, 45, 60, 120, 160. I think the 160. They had a 60 megabyte version. I think the 160 megabyte version was the largest of the DBA ESDI drive, and the layer model 70s came with that drive, and that's got integrated controller on the drive itself, on the circuit board, and it's considered direct bus attachment. It goes through. Basically, this is a truncated microchannel slot here. Only uses some of the signals, but is able to, that's what runs the drive, and everything else is one integrated unit, like a forerunner to the IDE, the PATA drives, the parallel IDE drives that had all the controller and drive integrated, and was a lot of the direct bus attachment. Now this is just plain ESDI. And so the controllers here, the drive was separate, more conventional. You had this as a data connection, and these were the control lines that you control line for the primary drive and then the secondary if it was present. And, but as I said, these microcode versions changed throughout time, and was very documented of the bugs and everything else that could occur with this controller. And that IBM wanted to get that latest version out there to go through. And this adapter did physically change a little bit over time, that some of the chips are oriented different ways or whatever, but the same basic adapter, just primarily that microcode changed to keep current or to quash the bugs that cropped up. And I'm going to develop a software utility just like that SCSI level to go through and tell, because there's about 6 different versions of this EEPROM that should be different microcode versions. And I haven't found anything from IBM that really went through and identified the microcontroller version. And what I do is I do a cross-reference to FRU to the EEPROM version. And that way I can just tell people, hey, you look for this EEPROM FRU, and it's got this level of microcode. And not that it concerns anybody, but this is a 04G, as in guy, 3759 microcode. And I don't see any EC change. I don't see any labels on the adapter. Otherwise, as we'll see in a moment with this. Okay, let's go through, and we're going to wrap up this video. It's going to be show and tell pictures that I'm going to get into now. Okay. Okay, and this is the adapter that we started the video at. This 2 to 8 meg memory expansion. And as I say, this is the version 2 EEPROM. Okay, close-up of the EEPROM. Version 2. Label scratched up a little bit otherwise, but... and let me show the back of the adapter. Okay, and we don't see any labels on top of down here at this bottom edge. Let me show a close-up of that. Okay, so there's the close-up of all the IBM FRU part number, all that. As I said, this adapter is known as that 15F8292. Okay, here's the close-up of the SIM slots. That CN1, CN2 that apparently may be the first positions populated, second position populated before you go to the other side. The EEPROM being up here in this upper left-hand corner. And as you can see, the plastic latches on either side. Okay. And that back bracket of that adapter. And, you know, just that piece of metal in this case there. And again, another view of the SIM slots. Okay, and this is the adapter that we put in there as a replacement, same style. That we see that FRU on there and the EC number. Close up of the EEPROM. That label's not scratched up. See a little bit of marks of maybe scratching the dust on it, but not much more. Scratches on the table behind it. Okay, and the back of the adapter. Now, down at the bottom, they have labels that are covering the silk screen marks that were there before. That's a close-up of the labels. And then we get to look at the SIM sockets. And on these SIM sockets are metal latches. A vast improvement from the plastic latches. We wouldn't have broken the latch if it had been metal instead of plastic. Most likely, they can stand a little bit more use and abuse in that case. And the back bracket, and that is a little bit improved there to where they have that more that piece of metal that loops around with a little bit more substance. And this is what IBM has on some of their higher end adapters. Just a little bit more reinforcement to kind of hold that back bracket piece and everything else there. So that's also physically improved on those adapters. So that later adapter was a nice thing to have. With those added improvements, that we can see the full picture here, and I'll have links to the high-res versions of these photos that I'll put up as well. But you can see the SIM slots, metal latches, that back bracket, that EEPROM in there with the good FRU to know that that's the latest or later version, and that EC. So a little bit more of an improvement over that early version of the adapter. Even though really otherwise, other than the physical changes, just that EEPROM basically fixed it as far as that softer angle. So we're back to the SkyCam and showing me, and that is a wrap after this very long segment here. So if you liked the information you learned about this video, and I apologize for it being so long and just those warts cropping up. I've got that heater going in the background. I've got the space pretty warm for me to start the upload here. As I say, I may just take the video home to use a faster connection there. Turn off the heater and get everything up. But if you like this video, go ahead and click on that like button. Subscribe to my channel and tell your friends. Let's get some, bring up the subscriber count, have some more people learning the good information here. And I apologize. Probably as a close, I'll learn what BOPT is. B-O-P-T. I'll pause the video, come back, correct myself, so it's all in the video. And then, of course, I'll have the appropriate description for the video and the links once I have it up as well. So I'll be right back with you. Okay, it came to me right as I didn't have the speakers blocked. So it's bypass one problem temporarily is BOPT. That's a sequence that IBM came up with. And once we go to the 32-bit adapters, and the initial versions of those are interesting. IBM had some getcha areas in those that you had to be aware of. And there's the 32-bit adapter. There's a version like this that's in 32 bits that seems to be pretty good. And it's also a 2 through 8 megabyte for the 32-bit system. And it's mainly the 2 through 14 megabyte 32-bit adapters that I want to talk about, because in those later videos of that BOPT sequence and how that basically the same adapter or a little bit of variations of it changed over time and were modified. And you see the bodge wires and things like that on those adapters. And who knows when I'll get to the point of pulling that out, and we'll actually upgrade the RAM on probably the Model 70. Start putting adapters in there. And these adapters, just like the 16-bit adapter here, was it has all the ADF and initialization file if it was needed, all on that the reference diskette for the Model 55SX and 65SX, since these were very common adapters. And it's a very nice way to upgrade the RAM in a 72-pin SIM to reach that 16 megabyte aspect. And certainly when we get into 32-bit systems, with them not being limited to 16 megabytes in a lot of instances of being able to exceed that boundary, having a lot more RAM. And that's where the issues are encountered, that direct memory transfers and stuff like that, and cacheable regions of memory and things like that. That's why those adapters had so much of an issue there. But we'll deal with those when we get to that. But hey, it's a wrap. We got through this together. And I've already mentioned, if you like the video, click on it, like button, click, share this thing around, tell your friends, subscribe to my channel, have your friends subscribe to my channel, get others in here too. But that's all I have for now. This is IBM Museum. Thank you.